We would kind of re-review it a little bit and re-talk this through. So you've got your notes out. We're reading this together. It says, a group of rock climbers traveling in the Southwest by car. Gear is carried in a minivan. They're also traveling in a car. How long will it take the car traveling at 60 miles per hour to overtake the minivan traveling at 50 miles per hour if the minivan started a half hour ahead of the car? And so yesterday we read that and we tried to draw a picture. And I asked you the question, where is it kind of implied that the minivan and the car started?
Same spot.
Same spot. So what I would do then in an effort to kind of picture this is I would say maybe the minivan is here. I'll just put M for minivan and it goes over there somewhere. And then the car is right here, starts right there in the same spot, and it goes over there. And it's implied here, of course, that the car is going to overtake or catch the minivan. And so we're going to use that here with the picture. I made the arrows the same length. That makes sense? So do the arrows, we can see that this involves distance and rate and time. Do the length of the arrows, does that represent distance, rate, or time? Distance. Represents a distance, yeah. So I'm going to put D sub C for the red car and D sub M for the green minivan. Okay, and then this is always kind of the challenge here to try to write an equation that will be helpful for us. So what can we say about those distances in relation to each other? Like an equation, literally something or other, blah, 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 with an equal sign. Katie, what do you think?
dm equals dc.
That's right. Distance of the minivan equals the distance of the car. And of course, this is different from the one we did yesterday. The other one, the distances were not necessarily equal. In this particular case, they are. So we really want to treat these on a case-by-case basis. Please don't think it'll always be this way or always be this other way. Take them on a case-by-case basis. Okay, so then our big discussion yesterday was, what do we do with the D, right? Because it's like, you look here at the question, it says, the question that's asked, how long will it take the car to overtake or catch the minivan? So how long will it take? What kind of a question is that? Time. And so our discussion yesterday revolved around, well, I don't see a time in there, but there really is a time, right? Yeah. D is the same thing as RT. Yeah, R times T. So I'd put rate of minivan times time of minivan equals rate of car times time of car. Something along those lines. Did I do that right?
No, just a lot. You're good.
Okay.
Rate of the minivan times the time of the minivan?
Uh-huh.
Okay.
So RT for the minivan equals RT for the car. That make sense? And I know that because I know that the distance of the minivan and the distance of the car are equal to each other. Now, we do know the rates, don't we? Isn't the car 60? So I think we could put 60 for the car and 50 for the minivan. But then we come up to the times. And the times, in this case, remember in the other one we did where wasn't it two planes headed towards each other or something?
Yes.
The times were the same, right? Didn't they start at the same time and end at the same time? Is it the same situation here? Are the two times exactly the same time?
No.
How do you know? Yeah, minivan got a head start. Yeah, so let's see here. Minivan had a half-hour head start. So as far as dealing with half hour, you could say half hour or you could say 30 minutes. Which one do you think would be wiser in this case?
30 minutes.
Why?
Because it's numbers,
Well, half is a number.
but it's harder to work with.
Oh, okay. So 0.5 or 1/2. Yeah, I agree. I would say here that half hour in the end is actually going to be quite a bit easier to work with.
The words half hour?
No, like the half, like 1/2. Like
That's
using.
what I was saying.
I thought you were saying like the words half
Yeah.
hour.
and I was
Oh,
like,
no.
that would be hard to
Like,
deal with.
would it be better to deal with a fraction, like 1/2, or a non-fraction, like 30 minutes? So it's miles per hour, so we want this to be in terms of hours. That makes sense? Because if we want this to be in terms of minutes, we could do that, but then we'd have to convert the 50 miles per hour over to miles per minute and the 60 miles per hour to miles per minute. That's going to take a lot more work than just saying, 30 minutes or half hour. It's easier to do half hour. Okay, so this will allow us to finish this one pretty quickly. which car, or I should say which vehicle, the car or the minivan, which one travels for the longer time?
The minivan.
Minivan, right? Because it gets a half-hour head start, but then they stop at the same time. So the minivan goes for a longer time. So what I'm going to do is I'm going to replace time of minivan with t plus 1/2, because the minivan's going for a half hour longer, and then I'll just say that equals 60t. This will allow us to find t here in just a couple of minutes, and that'll be the time that the car was driving.
Don't you send me the C?
You could. We actually can, the way that I've set it up, you can drop it, but I'd be okay if we had a little C right there. Oops, let's make that one a little bit more readable. There we go. Okay, so if we're going to solve this now, there's one kind of mathematical step before we get into solving, one simplifying step. What would be our simplification? Distributive property, yeah. So I'm going to distribute that 50 into the parentheses there. That'll give me 50 times time of the car plus 25 is equal to 60 times time of the car. I've got a time on the right side of the equation and a time on the left side of the equation. What should I do in order to simplify that? Combine them by what operation? Subtraction, yeah. So I'm going to subtract 50 TC from both sides. And I get 25 is equal to 10 TC. My final step would then be to do what? Division, yep. So divide by 10 on both sides. And we're going to get 2.5 is equal to TC. So 2.5 hours would be our units. All right. So, any questions from you guys? Okay. So what we're going to do here is we're going to leave the distance, rate, time, motion stuff alone for just a few minutes. We'll come back to it to finish things off. So if there's no questions, we're going to go ahead and move on to our final example in your notes. We good? All right. So here it is. Take a look at number 3. Okay, so again, very applicable situation, buying tickets to, in this case, a concert. Let's take a minute and read it and decide what we're going to do with it. Why don't you take a minute, please, and read it quietly to yourself. Decide if you understand exactly kind of the general idea of what's happening. We'll decide about pictures and equations, and then we'll try to solve. Okay, anybody describe in your own words what's going on here? It's a worthwhile exercise. What's the general idea? Like, have you comprehended this? Yeah, Levi, go ahead.
Okay, so tickets to a concert.
Yep.
They're $4 for students, $7 for adults, and $5 for seniors. Twice as many students as adults go, and then half as many seniors as adults attend the concert. And
Okay.
then the entire amount of money that was received was $875.
Okay. So you basically read it for a while, but then you did some nice kind of in your own words there for a little bit. He said, will you tell me, you said something like you didn't use the word total. You said, what'd you say, Levi?
Received.
The amount received. Yeah, so, or like the sum of the amount received or something like that was $875. When you hear the word total, what mathematical operation should you think of?
Equals.
No.
Equals percent.
Addition, I would say. Like when you go to the grocery store and you buy like 9 items, and then the cashier says the total is whatever, what did they do with the price of those 9 items?
Together.
They should have added them together. We hope that they didn't multiply them together. Probably could get really expensive, grocery bill. They probably added them together. So total, if I were you, I'd be looking at that and I would say, I need to be adding something up to get the total. So just maybe a little interpretation to help you get started. Who has to pay the most for tickets? Adults, okay. And then seniors are a little cheaper, and then students are cheapest, right, as far as how much the tickets will cost. Let me ask you this. What group, there are 3 groups, right? There's students, adults, and seniors. Which group has the most people attending?
Students.
Yeah, there's more students than anybody else. which one has the least number of people? Seniors are the least, and then adults, seniors, yes. Adults would be in the middle, right? They didn't have the most or the least. They're somewhere in between. So let's see here. We are supposed to, we got the total receipts for $875, and I got this 4, 7, and 5. What are my unknowns here? Like what is it that I don't know that I'm supposed to find?
How many unknowns?
Yeah, how many students? Yeah, number of students. So let's see here. I'll underline that. How many students attended the concert? And I'll just let you know there's a number of ways we could set this up. What I'm going to do here is I'm going to, off to the side, just to be consistent, I'm going to say that the number of students that attended was X, because that's an unknown. No idea how many. I just know that it's something I'm supposed to figure out. So in math, we usually make that a variable. But then we need to express the number of adults and the number of seniors. So I'm going to go ahead and put adults. Let's try that again. Number of adults right here and number of seniors right here. So if the number of students that attended was X, how many adults? X divided by 2, or you could say 1/2 X, right? Same thing. Yeah, you're right. Now, where did you guys come up with X over 2? What'd you say, Katie?
Well, because there's twice as many students, so like that's multiplication. So obviously.
Yeah, so adults, if there's twice as many students, wouldn't there have to be half as many adults as students? Yeah. So I'd say X over 2, or 1/2 X. Okay. So finally here we got to get the seniors lined up as far as number of seniors. So if there were X students and 1/2 X adults, how many seniors? 1/4. Yeah, wouldn't it be half of the half? Yeah. So it'd be 1/4. Now there are other ways to do this in which you mostly avoid fractions, but this is a way to do this. I want to make that clear that there's other ways to set this up. This was a natural way for me simply because I'm looking for the number of students. So why not make them X? Make sense? Okay. So then if I've got X students, here would just be sort of a general concept. If I've got X students and I know that they cost $4 a piece, how much money total did I get from students? 4 times X, right? So if each student is $4 and there were X of them, then the amount of money that the students paid was the multiplication of those, so it would be 4X. We can kind of sum this up here again in a second, but let's keep going. I need to find a total, so I'm going to go plus. Now there were 1/2 X adults, and they paid $7 each. So how much did we get from adults? Say again? $7 each, but there's 1/2 X of them. 3.5X. There you go. 7 times 1/2, right? Yeah. So it'd be 3.5X. Very good. We're just multiplying the cost of a ticket times the number of people that went. And then lastly, we have the seniors we need to add in here. So there was 1/4 X seniors, and they each paid $5. So, say again?
Is it 1.25?
It is 1.25. Yeah, 1 1/4. Yeah, so 1.25X would be the amount of money that we got from senior citizens. Okay, so if I take all those amounts of money and I add them up, I should get the total, and the total was $875. So that's our setup. We'll do the equation solving and simplifying here in a moment. Do you guys have any questions about where we got each of those terms? The 4X, the 3.5X, the 1.25X? Just multiply ticket cost times number of people. Ticket cost times number of people. Say again?
Can we just add up like the 4x plus the 3.5x plus the 1.25x?
Yeah, we'll do that next. Yep, absolutely. Question though first. Can you, sorry? Oh, yeah, go ahead. Okay, so let's take Issa's advice here and let's add up our like terms. I think that's exactly what we need to do. So if we add that whole left side up, what do we get? 8.75x, that's right, equals, look at this. This is going to work out really nicely as far as numbers go. Divide both sides by 8.75 to solve this. And how many students showed up? 100. So x equals 100 students came to this Concert. Okay. Certainly other things could be asked here. Let's just ask them now. If there were 100 students, how many adults showed up? 50. And how many senior citizens? 25. So those are other questions that could be asked along with this one, but we've answered it, so I don't think we have to do that. Okay. Are there any questions before we leave this one alone? Go ahead, Keely.
Is this like, this isn't the D equals RT, right?
Not really. There is a connection to be drawn here, and I can draw that connection here for you. But there's no distances or rates or times. There's kind of a rate here, and so I'll tell you what. Let me just use I'll just use the whiteboard for this, and I'll try to draw the connection here for you. I am recording this, and so if you need to go back and watch this, please do. Please make use of that as a resource. All right, so here we go. It says 2 drones are launched from the same place in opposite directions. So from a picture perspective, I'm going to put a dot right here, and I'm going to have one drone go to the right, and I'm going to have the other drone go to the left, because they are going in opposite directions as described in the first sentence. One flies east at X miles per hour, the other one west at a rate of 5 miles per hour faster than the other drone. It goes on to say some stuff about 3 hours later, they're 600 miles apart. But I want to label my picture. When you label your picture, please always label your picture with distances. I'm going to call this one, the orange one, distance 1, and I will call the green one distance 2. Very, very simple labeling. One's for one drone, the other one's for the second drone. But then I need to incorporate the 600 miles, and they are 600 miles apart at the end. And so what I'm going to do is finish my picture by stretching out 600 miles all the way across the whole thing. In the end, they will be 600 miles apart, and that represents kind of the total distance. So walking around, I saw a lot of folks had pictures either just like that or close to that. The one exception is there's definitely still kind of an urge to label those arrows with rates or maybe times, and I don't think that that's best. I think labeling it with distances is best. So what we need to do now is we need to write an equation that relates all that stuff. So what is an equation where you got blah, blah, blah equals blah, blah, blah? How do you relate these things together? Katie, maybe?
D1 plus D2 equals 600.
Yes, that's exactly right. I'm going to say D1 plus D2 is equal to 600. And you should be able to, if you draw a good picture, you should be able to see that from the picture that little distance plus other little distance equals big distance, right? Does that make sense?
Yes.
So, again, I don't want you to overthink this. Look at this, look at the picture, draw a good picture, and write an equation based on the picture. And don't worry about the rates or times yet. We'll do that next. Bless you. Okay, so then what I'm going to say after this is, I don't see any rates or times up there, and it does say, what is the speed of each drone? So I need to convert my distances over to what distance really is, and that is rate times time. Yes. So it's going to be R1 times T1 plus R2 times T2 equals 600. And of all those R's and T's up there, don't we know some of them? What do we know? We can express the rates, and we will, but we know one of those things immediately. The time is 3. So I'm going to put 3's in there for the 2 times, so it's going to be R1 times 3 plus R2 times 3 is equal to 600. But finally, I don't know exactly what the rates are. I can relate them together, but I don't know exactly what they are. What does the question tell us about the rates? One of them's faster. Yeah, one of them's faster than the other, and like Lydia said, exactly 5 miles per hour faster. So it doesn't really matter which one you do here. I just need to pick one of my drones to be faster. So I'm going to say R1 times 3 plus R1 plus 5 times 3, indicating that one of the 2 drones, in my case the second one, but it doesn't really matter which one is which, one of the drones needs to have a rate that's 5 miles per hour faster than the other one. So just add 5 to one of the 2 rates, and that shows that one of them is faster. So I noticed up here, you guys actually came up with this, more or less, but you didn't have parentheses. And I think the parentheses are going to be what maybe hurts you in the end.
Yeah,
So,
and we forgot the, like, little numbers, so we added the two R's together.
okay. Well, you know what? They're the same R. They are. Because one of them,
Maybe I'm just really confused.
the second one is, well, if you think about it, the second one is 5 faster than the first one. So at this point, it would be one of them's R1 and the other one is R1 plus 5.
Okay.
So I don't think you're wrong on that at all. So I'd go 3R1. Distributed property gives me 3R1 plus 15. And I think it's the 15 that hurt you there because I think you guys subtracted 5, perhaps.
Oh, yeah.
Yeah. Okay, so maybe coming over here, I would then get 6R1 plus 15 is equal to 600. Subtracting 15 from both sides, I get 6R1 equals 585. I've got to divide by 6. Can you guys help us out here? 585 divided by 6?
285.
You, the 3 went away at the end. Where did 3 go?
Which 3?
You times it.
Are you talking about that 3?
Yeah, what happened to the 3?
He got distributed. Distributed property in there, 3 times R1, 3 times 5.
Oh, they're supposed to distribute the 1 and the 1.
Hold on. So you're saying you thought you should distribute that one?
Yeah,
Onto what?
the R1 and 5.
No, actually that's not what you do, and the reason why, Lydia, distributive property is always going to be something times parentheses, and that 3 is actually, there's a plus sign in between, so we would not distribute it in that way. Okay, so you guys said 97.5, did I hear that right? Yeah. Okay, so R1 then equals 97.5. That means that R2 is how much? 102.5. It's 5 more than that. So those would be your 2 answers right there. 97.5 miles per hour and 102.5 miles per hour. I saw that at one point. I thought I saw it over here, Brayden, with yours. No, was that maybe? I thought maybe you had that and then erased it.
197.
Oh, okay. I saw something like that. Yeah, go ahead.
Question, so couldn't you just, like, the two, like, distances, couldn't you just divide it by half, and then the 300, divide that by 3, and then make sure that one is 5 more than the other?
Yeah, but then how do you show your algebra work for that?
I don't know, but isn't that just faster and easier? And
Remember, you got to keep in mind. We're talking about the other one now, the cyclist leaving home base. It's right here, leaving the training base. So guys, let's put in some real work here. Let's draw pictures. Let's try to write equations like we've been practicing. If we don't have time to maybe totally finish this one here today, we'll do it first thing on Tuesday when I see you, but just more practice here. So I would say, you got your distances. Yeah. You got your distances like so, when we got distance of support, or I'll put distance of car, distance of support, distance of cyclist, they're equal to each other, right? And so it would be rate of support car times time of support equals RCTC. Now the rate of the car is 55. The time is, we don't know yet. The rate of the cyclist is 22, right? I know that the cyclist started 2.5 hours before the car. I don't know that either one of them, in fact, I know that they went for more than 2.5 hours, right? Because the cyclist kept on riding after the 2.5 hours. So I would say that the cyclist, I'll put it like this, the cyclist went for 2.5 hours more than the car did. Right, so what I've got here,
So it's times T.
what's times T?
The 2.5 is
It's plus.
plus T.
Right, so if I go for 2.5 hours more, that means that my time was 2.5 hours plus yours. And so I would say the cyclist starting 2.5 hours early his time would be time of whatever the support car was plus 2.5. At the time the support car was just T. Yep. And so, at this point, you'd get a distributive property, and this normal equation solving there. But to me, it's getting to this point, right? Because I feel like you guys can probably all handle that from there. It's getting to that point. Just so you know, the answer, if you round it correctly, ends up being 1.7.
I see it.
1.7 hours. So something to think about there. You can refer back to this if you want to see answers and stuff like that. So yeah.